What's up guys, low-key high yield here with a video explaining the different types of shock. This is a super high yield topic for step 1 pathophysiology and for step 2 management. Regardless, if you're in medicine at all, you're going to work on a medicine floor, you're going to work on an ICU, and knowing this stuff will be important in real life. So let's lock in and learn about shock. We can start by defining shock. This is when not enough oxygen is delivered to the tissues in order to maintain vital organ function. Hypovolemic shock happens when you lose blood or fluids, like in a hemorrhage or severe dehydration. Because there's not enough fluid in your blood vessels, cardiac output drops, pulmonary capillary wedge pressure or preload drops, and peripheral vascular resistance increases to compensate. First-line treatment is rapid fluid resuscitation. You've lost fluids, so now you need to replete them. Cardiogenic shock is pump failure, which can result from myocardial infarction, cardiomyopathy, heart failure, arrhythmia, basically anything where the heart is not functioning properly. Cardiac output is low, as would be expected with a cardiac problem. But preload is high, since blood is being returned to a heart that isn't pumping out that same blood. Vascular resistance is increased as the body tries to compensate for this decreased cardiac output. Inotropes, like dobutamine or milrinone, can increase the strength of cardiac muscle contraction in order to improve this failing cardiac output. If these don't work, mechanical supports like an intra-aortic balloon pump or ventricular assist devices can be tried. Obstructive shock means that blood can't get out of the heart and to the rest of the body because of an obstruction. This could be a massive pulmonary embolism, cardiac tamponade, or even a tension pneumothorax. As a result of the obstruction, cardiac output drops and vascular resistance increases to compensate. At first, preload's going to be high since the blood is backing up behind the obstruction, but as this obstruction persists, less blood is going to reach the left ventricle. This is shock after all. Treatment involves addressing the underlying cause, so thrombolysis for a pulmonary embolism, chest tube for a pneumothorax, or pericardiocentesis for tamponade. We're almost done, just got to talk about distributive shock. Distributive shock is widespread vasodilation, meaning that vascular resistance will be profoundly decreased. As a result of this, less blood is able to return to the heart, meaning less preload. Cardiac output, on the other hand, will increase as the heart tries to compensate for the widespread vasodilation. At this point, you might be thinking, wait, what about septic shock or anaphylactic shock? These are actually types of distributive shock, which we'll talk about now. In septic shock, microbial toxins and the body's immune response cause widespread inflammation and endothelial activation. These are what lead to the vasodilation seen in this form of distributive shock. Gram-negative bacteria release something from their cell wall called LPS, which drives this cascade. Treatment starts with crystalloid fluids and then vasopressors like norepinephrine if fluids aren't enough. Don't forget to get blood cultures and then start broad-spectrum antibiotics. Anaphylactic shock, on the other hand, causes distributive shock through a massive release of histamine, a molecule which induces vasodilation. Anaphylaxis is treated with 1 to 1,000 epinephrine and potentially antihistamines and steroids. A systemic inflammatory response can cause distributive shock too. When there's a strong insult to the body, like trauma, burns, or pancreatitis, inflammatory mediators will be released systemically, causing that widespread vasodilation. Treat the underlying cause here. The last type of distributive shock is neurogenic. In neurogenic shock, an injury to the descending sympathetic pathways in the brain or spinal cord, which maintains sympathetic vascular tone, cause unopposed parasympathetic activity and subsequent systemic vasodilation, along with relative bradycardia. For some reason, the USMLE loves spinal cord injuries and neurogenic shock, so remember that on test day. We treat this form of shock by maintaining pressures the best we can with fluids and pressor support. Now let's do some practice questions to test your knowledge. First one, a 35-year-old male developed sudden hypotension, distended neck veins, and muffled heart sounds after a traumatic chest injury. His EKG shows low voltage QRS complexes. Which hemodynamic pattern would you expect initially? Pause the video if you need more time. Our answer is B. You might have noticed the hypotension, distended neck veins, and muffled heart sounds making up Beck's triad in the question stem. Beck's triad is characteristic of cardiac tamponade, a form of obstructive shock. In this form of shock, blood backs up behind the obstruction, leading to a high pulmonary capillary wedge pressure. Cardiac output is low due to impaired ventricular filling, and SVR increases to compensate. Definitive treatment will be with pericardiocentesis. Next question, we have a 70-year-old man presenting with fever, hypotension, tachycardia, and confusion. Blood cultures later reveal gram-negative rods. He's already gotten 2 liters of crystalloid fluids, and he's still hypotensive. Which of the following is the next best step in management? Pause the video if you need more time, but our answer here is B. Start a norepinephrine infusion. Septic shock is a form of distributive shock caused by systemic vasodilation. If fluids fail to restore perfusion, the next step here is going to be to give a vasopressor like norepinephrine. Don't forget about getting cultures, broad spectrum antibiotics, and source control is also always great in bacteremia. All right, last question here, guys. We have a 25-year-old male who is admitted after a high cervical spinal cord injury. He's hypotensive with bradycardia, warm, and flushed. Which hemodynamic pattern differentiates neurogenic shock from the other forms of distributive shock, such as septic or anaphylactic shock? Pause the video if you need more time, but our answer here is C, bradycardia with hypotension. So this person has a spinal cord injury, meaning they're at risk of developing neurogenic shock, and that comes from a loss of sympathetic tone leading to unopposed parasympathetic activity. This will cause hypotension and relative bradycardia, which distinguishes it from other kinds of distributive shocks. In shocks like septic shock, anaphylaxis, there is a widespread vasodilation, but the body's able to compensate by increasing the heart rate. In neurogenic shock, these descending sympathetic tracts are knocked out, meaning the body is unable to produce this tachycardia, and you get a relative bradycardia instead. Here's a summary chart of everything we went over today. Something that helped me was covering up different parts of this chart with my hand or a post-it note, and then quizzing myself on the different factoids. Feel free to take a screenshot here and make sure you know this information cold. Alright guys, that's it for shock. Please, please, please like and subscribe, share with your friends if you found this helpful, and comment any ideas for future videos you'd like to see. Thank you for watching and happy studying.